वालेकुम सलाम। Assalamu alaikum, sir.
Alaikum salam.
Assalamu alaikum, sir.
आ गई।
Assalamu alaikum to everybody. In the last class, we were discussing about problems of Planck's quantum theory, right? Our discussion was something different. We were actually discussing about structural arrangement in terms of atomic structure, and we were trying to enjoy models. And for that purpose, we have taken Rutherford's model, but there is a difficulty that we have two problems with that model. One is we are unable to explain stability of an atom, and the second one is we are also unable to explain existence of line spectrum. These two were the drawbacks in Rutherford's model, and because of those two drawbacks we are having an idea. Let us try to see what is the way with which we can have elimination of this one. In doing so, we come across one more person by name Mr. Planck. He suggested that release of energy or gain of energy is not a continuous process. And the thought of discontinuity came from an idea. Experimentally, atoms always gives you line spectrum. Since you are having availability of line spectrum, therefore, remember that there must be a gap, because in line spectrum, what happens? We have a color, we have energy, we have wavelength. There is a gap. Color, another energy, another wavelength. Again a gap, again the gap, again a gap, like that. It means to say there is no continuity available. On that basis of existence of line spectrum, Planck suggested that emission of radiation or absorption of radiation must be a discontinuous process. That's all. And then people are thinking about what to do. One person by name Neil Bohr, right? No experimental discussion, nothing. Simply calm and quiet. A corner of a room, a table, and a white paper, and a thought process. What he was planned, just he completely relied upon one statement of Planck's quantum theory, that loss of energy from a body, gain of energy into a body is a discontinuous process. So he just take up that language, discontinuous. He was just thinking on that one. What do you mean by the word discontinuity? Why we are getting line spectrum? Why we are not having color continuity? There is a color. Why we are having a gap, then another color? Why we are having gap, then another color? He was just only thinking on that basis, and then he has got a very beautiful idea which was successfully accepted to overcome all the difficulties of Rutherford's atomic model. He suggested Bohr's atomic model. Who is that fellow? This fellow. He suggested that electron, first point, no one is going to touch till today, that nucleus is the centrally located, smallest, densest, positively charged part of an atom. Yes, till now everyone appreciate the approach of Rutherford's model. But second point has been removed, and he added that electron revolves around the nucleus. See the comparison, compare, go to the previous one. What you said, electron is revolving around the nucleus, identical to planetary motion. A very rough way of statement. Now he systematically proposed that electrons are revolving around the nucleus in fixed circular paths. The words fixed circular paths. What is the beauty left out or hidden inside this one? Sir, if we are saying that they are moving in fixed circular path, means they are not going to follow spiral paths. right? And once you are having spiral path, there is a chance of unstable character. But now we are saying no, no, it has to revolve around the nucleus in fixed circular path, right? As long as electron is revolving around the circle. If you know physics to some extent, then you can say, sir, whenever we have circular motion, there will be force acting towards center known
Mhm.
as centripetal force. In our case, it is called electrostatic force of attraction by the nucleus over the electron. And a body which is revolving in circle should have always a direction of motion, displacement in tangential direction, and the angle made between displacement and force is 90 degrees. And if you know physics, you can say, sir, work is equal to Fs cos theta, and cos 90 is 0. Work done is equal to Fs into 0. That means the amount of work done by the nucleus over the electron revolving in circular path is equal to 0. When there is no work done by the nucleus, there will be no change of energy. It will neither have loss of energy nor gain of energy. Since it is neither having loss or gain, it will follow same circular path. As long as electron is revolving in a specific circular path, its energy remains constant, its velocity remains constant, its angular momentum mvr remains constant, its distance from the nucleus remains constant. All these properties are constant even though electron is in motion. Electron is not at rest, electron is in motion, but properties are constant. Therefore, what Bohr suggested, that if electron is revolving in circular path, this circular path must be called as orbits, and these are called stationary orbits. Why they are called stationary orbit? Electron is revolving but behaving as if it is a rest particle, right? Bus is at rest, bus station. Train is at rest, railway station. Exactly in a similar way, stationary orbits are those circular paths in which electron is revolving, behaving as if it is rest because its properties are not changing. Hence, name is given as stationary orbits. And these stationary orbits are given by, denoted by some number called principal. Principal, your college principal spelling, principal quantum number, small n, 1 2 3 4 5 6. Remember, quantum number means if you are talking about 1 2 3 4 5, you cannot have 2.5, you cannot have 1.25. That means you are sitting on the first floor. Sir, I am sitting on the second floor, I am sitting on third floor. One fine day, one boy says, sir, I am sitting on 2.5 floor. Not at all possible. This is known as quantization. Electron is either available in the first orbit or second orbit, right? This energy of first orbit, x, energy of second orbit, y. In between x and y, there are so many energies available, but electron cannot enjoy those energies. First floor is at 10 foot from ground floor. Second floor from the earth's surface, it is 10 foot. Second floor is 20 foot from the earth's surface. You are saying, sir, I am at 10 foot. You are right. So you are saying I am at 20 foot, 30 foot. Someone says, no, no, I am at 10.25 foot. Not at all possible because there is no floor available there. Exactly in a similar way, energy of electron is quantized. Once you are saying energy is quantized, then you can say, yes, sir, electron has to occupy or enjoy specific energy only. You cannot occupy any possible energy. This means to say that suppose, for example, you are coming into the classroom, right? In the classroom, nice benches are arranged, everything is fine. Students are coming and systematically sitting on the right and left hand side of the benches, right? One fine boy, XYZ, came in the classroom and said, sir, today I want to sit in between the benches. There is a space. I want to sit here. I said, no, beta, you cannot sit there. He says, sir, this is the part and parcel of classroom. Yes, it is not allowed for students, right? Similarly, electron is supposed to be available, enjoy certain amount of energy. Electron has to enjoy certain amount of energy. It cannot enjoy all possible energies. All possible against quantization. Specific possible, quantization. That is the meaning. I am repeating particularly because quantum theory, quantization word you have to understand in a proper way. All right. Once you are saying this one, then let us see, try to enjoy what he said. This atomic model is based upon concept of quantization proposed by Mr. Planck. Bohr's postulate may be summarized as number one, electron revolves around the nucleus in fixed concentric number of circles with same center. Number of some circles with same center known as shells. People used to call shells also, but correct proper name is orbits. Shell is not a wrong name. You can say shell also, but most common word is orbits. Orbits, take care of that. Next, see this one. This is the way with which electron will enjoy their life. They are always revolving in the same orbit, right? And this is known as a stationary orbits. They are always having their own path, okay? Next, suppose for example, if electron is revolving in a specific path, its energy is constant, right? Each orbit is a fixed amount of energy. As long as electron revolves within the same orbit, its energy, En, is constant. These are called stationary orbit. These are called stationary orbits. Nice. Each orbit is given by a principal quantum number known as N, denoted is N, 1, 2, 3, 4, 5. Some people say KL, MN, capital letters. Yes, they are also applicable. Sometimes question will be asked, electrons in M shell. Okay, it means to say it is in third orbit. Like this, we are having a nucleus. We have first, second, third, fourth orbit. No, sir, they can also be K shell, L shell, M shell, and N shell. Usually, the language is like this: first orbit, second orbit, third orbit, right? K shell, M shell, L, like this. For KLMN, we use the word shell, and for 1, 2, 3, we use the word orbit. Not a problem. Okay, next. Now, as you increase the principal quantum number, energy of electron also increases. That means those electrons which are close to nucleus, they are having very less amount of energy. As you increase the electron in a distance of the electron, as you increase the principal quantum number, they go far away from the nucleus. As they go far away from the nucleus, remember, electrostatic force of attraction decreases. They will not be under the control of nucleus, therefore their energy is more. They can do anything, as if in the classroom, those students who are really interested in the subject and they want to learn and a proper rank, usually they come early and they try to occupy first, second, third benches. And those students who want to say, come on, let us go and enjoy something unnecessary, they will try to occupy always last benches, because they will be under the less control of the nucleus. As they go away from the nucleus, control of the nucleus, electrostatic force of attraction by the nucleus over the electron will be less, their disturbance energy will be more, right? That is E1 is least possible energy, less than E2, less than E3, less than E4, dash dash, less than infinity. What is that means? It means every atom has infinite number of orbits. Yes. We don't count them, that is a different story. Why we don't count them? Every classroom has very large number of benches, but I count only those benches on which students are sitting. We have to count only those orbits in which electrons are available. For hydrogen, first orbit, enough. But it does not mean to say there is no orbit. All the orbits are present, they are empty. Sodium, third orbit, enough. Potassium, fourth orbit, enough. This means to say every atom has infinite number of orbits, but we count only those orbits in which electrons are revolving. Suppose, for example, you want to say, sir, I want to jump the electron from lower orbit to higher orbit. No problem. It can be done. How it is possible? Give necessary amount of energy. Electron is revolving in the first orbit. Suppose, for example, energy is equal to X. In second orbit, energy is equal to Y. Supply difference between them, Y minus X. They will jump up, right? But listen carefully. I am giving one example. Here I am choosing numbers which are not correct, but for your mind understanding it is suitable. Therefore, I am going like this. Suppose, let us say the energy of first orbit is 10. This is wrong. It's not 10. It is something different. We'll calculate that later on. This is 10. Second is 20. Third is 30. Fourth is 40. If suppose you are having this one, then roll number 1 says, sir, I want to jump electron from first orbit to second orbit. Roll number 2 suggests him, no problem, do one thing. Take energy of second orbit, 20, energy of first orbit, 10, 20 minus 10, supply 10 units of energy, electron will jump. It is called endothermic process. That means if electron is to be jumped from lower state to higher state, lower energy state to higher energy state, lower principal quantum number to higher principal quantum number, energy has to be supplied. Energy has to be supplied. Suppose, for example, electron is getting de-excited. Sir, I want to have jumping of electron coming back from higher to lower, energy will be released. It is called de-excitation process, and it is exothermic process. Energy is released. For example, see here, when electron is coming back from higher orbit to lower orbit, E3, E2, E1, it's coming down. Energy is released. Take care of the arrow mark. It is called exo process. No, no, sir. If I want to take up the electron from this orbit to higher orbit, then I have to supply energy. That is called as excitation of electron, endothermic process. It is supposed to be endothermic process. Fine. Now there is a small interesting problem. What is the problem? Rule number 1 says I want to excite the electron from first to second, and according to my assumptions, energy is 10 and 20. Rule number 2 said command supply 10 units. Why? He said, I had to go from 10 to 20, supply the energy 10. Rule number 3 said, no, 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 do one thing, supply 10.2. You require 10, na? Come on, supply 10.2. What happens? It will be very much advantageous. Remember, clearly understand, electron will never accept energy which is either slightly more than difference of energy or slightly less than difference of energy. This is the key discussion known as quantization. Quantization of energy means if difference between the energies of two different level is 10 units, you should supply only 10 units. If you supply 10.1, 10.2, 10.3, no, it is not possible to accept. Remember that if suppose you are jumping from 5th floor, right? Let us take just imagination. If you are jumping, you can say, sir, I can jump from 5th to 4th, 4th to 3rd, 3rd to 2nd. One boy say, no, no, sir, I am jumping from 4th floor and I am resting for 10 seconds at 2.5th floor. It is not possible because that height does not have allowed position. There is no floor available. Exactly in a similar way, electron can enjoy only permitted orbits, permitted energy levels. Remaining in between, we have energy. Suppose you are saying energy of first orbit is 10 and second orbit is 20. Don't you have 11, 12, 13, 14? Yes, energy is available, but that is not permitted energy. When you go to second year physics, you people call this as forbidden energy, not available energy. The space between two rows of benches is the space of the classroom, but you are not allowed to sit there. It is not permitted. That is the meaning of quantization. If you want to jump the electron, then supply the energy exactly equal to difference of that. For example, E is equal to energy of higher orbit minus energy of lower orbit. And that must be quantized, must be h nu, 1 h nu, 2 h nu, 3 h nu, any number of h nu, but cannot be 2.5 h nu, cannot be 1.5 h nu. That is called quantization, right? This n is called principal quantum number. It can be also in terms of hc by lambda. If suppose electron is revolving around the nucleus, then as long as it is revolving in that orbit, see it is in second orbit. What happens? If suppose energy is released, it will go down, right? And suppose, for example, if energy is given, it will jump up. That is the meaning of excitation of electron, endothermic process. De-excitation of electron, exothermic process. All right. Next point. Now, when this has been explained, people were very happy to enjoy the concept of a constant path, circular path, and loss of energy, gain of energy. Then people asked Rutherford Bohr, let us talk about position of electron. You are saying electron is revolving in specific circular paths. Which path? First orbit, second orbit, third orbit. Where is the electron present? He said, if you want to locate the position of electron, calculate its angular momentum. What is angular momentum? MVR. M into V, linear momentum. MVR is called angular momentum. Bohr suggested that if suppose, for example, angular momentum MVR is equal to 1 into h by 2 pi, electron should be in the first orbit. 2 into h by 2 pi, electron should be in the second orbit. 5 into h by 2 pi, electron is in the fifth orbit. It cannot be 2.5 into h by 2 pi. If electron is available in nth orbit, its angular momentum should be n into h by 2 pi. So he suggested the position of electron is restricted in such a way that angular momentum of electron is integral multiple of a factor called h by 2 pi, that is mvr is equal to n into h by 2 pi. This statement, this postulate of Bohr restrict the position of electron. Where is the electron? How to find out the position of electron? What is m? Mass of electron 9.11 10 power minus 31 kg SI units. V is velocity of electron, and radius of the orbit r, and then principal quantum number, and your old friend Mr. Planck's constant, right? This means to say that according to Bohr's theory, we have electrons revolving around the nucleus in fixed circular path known as stationary orbits. As long as electron is in a particular stationary orbit, its distance from the nucleus, its velocity, its angular momentum, its energy remains constant. Therefore, they are called stationary orbits. If electron jumps from lower to higher orbit, energy is absorbed. Excitation of electron, endothermic process. If electron is jumping back from higher to lower orbit, de-excitation of electron, exothermic process, and the amount of energy absorbed or released must be quantized. Go back, Planck's quantum theory. This fellow is discussing under the shadow of Planck's idea that loss of energy or gain of energy must be a discontinuous process. Now the question is, okay, sir, nice. If it is so, what are the advantages? What are the plus points of this theory? Very simple and very beautiful. That suppose, for example, if you are accepting electron is revolving around the nucleus in stationary orbit, there is no question of unstable character. That means Bohr was able to successfully explain stability of an atom in terms of stationary orbits, right? Because there is no chance of spiral path available here as long as electron is revolving in stationary orbits. Remember, its energy remains constant. Therefore, Bohr's first acceptance or first point we have to say appreciate that it explains stability of an atom in terms of idea of stationary orbits. Next, if electron is jumping from higher level, lower level, suppose for example, electron is coming from 5 to 4, energy is E5 minus E4. No, sir, it is coming from 5 to 3, 5 minus 3, 5 minus 2, 5 minus 1. All these are not same. Energy E5 minus E4, E5 minus E3, E5 minus E2 will be different quantity. If it is different, it will give you different energy. If it is different energy, it will give you different lines in the spectrum. Yes, we can explain the existence of line spectrum due to quantization of energy. It also explains existence of line spectrum for an atom due to quantization of energy. These two are the points with which we can say all the problems of Rutherford can be completely removed and we can enjoy, yes sir, it is said to be a proper way of understanding the structure of an atom. But in science, there is no full stop. In science, there is always a comma which says that you have still certain drawbacks in this model. And that is our enjoyment, that if we learn the drawback, we can go ahead to improve the way which we can say, sir, I am trying to understand better and better because I know my difficulties. What are my drawbacks? I know, therefore I can improve myself. What are the drawbacks? We'll discuss later on. First of all, write down this much. Any question to ask? Suitable question to ask. If so, please go ahead. Otherwise, write down. Take a fresh page, atomic structure, section C. We are discussing section C. Section A, Rutherford's model. Section B, Planck's quantum theory. Section C, we are writing Bohr's atomic model, and write down all as it is. Abdullah Sohail, There is an equation given by Rutherford Bohr's, but it is a thing to understood here. He said it is like this. Nothing to understand because I have not derived that expression. When you use the word understood means I have derived and you are not able to understand. I said Bohr suggested if you want to locate the position of electron, find angular momentum. Value of angular momentum is 1 into h by 2 pi. You got it like this. Then what to do? You have to say electron is in first orbit. Nothing to understand there. That is an equation. Yeah, yes. Now it is like a formula for you. Once I go ahead, then I'll say, no, I can derive this also. It is just a formula now. Instead of saying formula, better to say it is an expression. It is an expression. Scientific language is it is an expression proposed by Rutherford. And all these are called postulates. Postulate means a statement which has no practical proof. Simply he has said, simply sitting on the paper and thinking. They are called postulates. We accept postulate if results are experimentally proved. Yes, that is merits. Because we have advantages, we have to say, yes, sir, these are the correct postulates. It's not a formula. Faiz, just read again what you have written properly. I think what you have asked, is it correct? What you want to ask is different and you are uh, asking something different. Is it over? Right. Abdullah Sohail, I am not discussing about quantum numbers. I have never discussed about the quantum numbers. I don't know who is Schrodinger also. Now, Faiz Nawab is asking if the energy required is 10 to move another orbit, but it provided 10.2. Remember that in that case, electron will remain in the first orbit. It will not jump to second orbit. It will not accept, I said. It means it will not going to jump that one. Is it over? Right. Now the question is, yes, you are right. Velocity undergoes a change. Not only velocity changes, distance of electron from the, I think if you are able to observe the figure, first figure, see the velocity, see the speed of electron in first, second, third, fourth. I try to enjoy everything on the screen. I am collecting so many things here, right? Therefore, when we are discussing, yes, distance of electron from the nucleus changes, velocity changes, energy changes, right? How it changes, that I am not discussing. I am saying it changes. One thing I have discussed, energy increases, I said. Distance also, of course, you said increases. Now, velocity and all remaining things, we'll learn one by one, we'll learn it one. Now, come to the point. Electron in the first orbit. Khadar Mustafa is asking electron in the first orbit. Remember, energy is least in this case. That means you are in the ground state of the building and you cannot go further down. That means least possible energy is supposed to be the E1 value. Electron in any case cannot occupy energy less than E1, right? Energy will be always more than E1. Is it clear? Next. Muhammad Abrar, see that statement, what is the figure given to you, right? What is the meaning of energy of higher orbit and lower orbit, that all given to you.
To
Any other question? Is it clear now? Abrar, is it clear? Fine. Now the question is, what is the problem? The problem is, sir, we are having difficulties. What are the difficulties? Listen carefully. I am saying that it explains stability of stationary atom in terms of stationary orbits, and it also explains existence of line spectrum for an atom due to quantization of energy. But there is a problem, very big problem. The problem is both of these ideas are applicable only in case of uni-electron system. That means, yes, Bohr's theory is very, very, very much applicable only with respect to hydrogen or any other ion where you're having one electron. For example, helium ion, right? Lithium ion, beryllium ion, full stop. Helium atomic number 2, remove one electron, helium ion. Lithium atomic number 3, remove 2 electrons, we are having lithium 2 plus. Beryllium 4 electrons, remove 3, beryllium 3 plus. So all uni electron, only 4, hydrogen, helium ion, lithium 2 plus, beryllium 3 plus. For only these systems it is applicable. And spectra stationary, both of this can be applicable only for uni electron system. But suppose, for example, if you are having multi electron system, it is not applicable. Naturally, you may have a question, sir, what is the problem? Why it is applicable only for uni electron system, not in case of multi electron system? It explains stability and existence of line spectrum for an atom only in case of uni-electronic species or species isoelectronic. Isoelectronic means same number of electrons. Isoelectronic to hydrogen, such as helium plus, lithium 2 plus, and beryllium 3 plus, and not applicable for multi-electronic species. If you have more than one electron, yes, it is not applicable. Question is, sir, what is the problem? Okay, first write down this much. I will go to next slide. Fine. Now, the problem is why we are not able to apply. Come on, see here, what is the problem? The problem is something like this. This is uni-electron system. When you discuss about this, there is one electron and there is the nucleus, right? You may have any number of protons, no problem. Our discussion is not uni-proton. I am saying uni-electron system. There will be a force. Which type of force? Electrostatic force of attraction. Remember, here in this case, we have only one type of force available. Bohr has taken into account of only this force, the electrostatic force of attraction. And remember that if you are having multi-electron system, yes, nucleus, electrostatic force of attraction, electrostatic force of attraction, electrostatic force of attraction, But at the same time, there is one more force known as repulsive force. This repulsive force among the electrons in case of multi-electron system has not been counted by Bohr's atomic model. Therefore, it is not applicable in case of multi-electron system. It is applicable only in case of uni-electron system. Both electrostatic force of attraction and repulsions do exist in case of multi-electron system. Now see this one, right? Here we are having a system that is given energy, principal quantum number 1s. See carefully the figure arrangement of energy. Energy of 2s equal to energy of 2p. Energy of 3s equal to 3p and 3d, right? Now, anybody in the class, if belong to state syllabus, can you tell me anything is wrong in this figure? Have a close look on this one and just check up and tell me, is it correct or something is wrong in this figure? He is saying energy of 2s equal to 2p, 3s equal to 3p equal to 3d. Is it correct? Okay, Muhammad Isa is saying energy of 2s is less than 2p. Excellent, correct. Saidur Rahman say it is not correct. Very good. Now see this figure. See this one? Yes. This is the figure which you have learned in your 10th class. Energy of 1s less than 2s, less than 2p, less than 3s, less than 3p, then 4s comes and then 3d. Why all these disturbances between 2s, 2p? Repulsive force. Yes. The Euler's diagram which you have learned in your 10th class and the arrangement of energy of different orbitals, right? CBSE, ICSE people may not be able to understand this one because they don't know 2s, 2p, 3s, 3p, all that. In future, you may learn in our class all these things. So if you are having this arrangement, this is true in case of multi-electron system, and this is true in case of not hydrogen alone. It is applicable for all uni-electron system because all these orbitals are empty. When there is no electron available, we don't count those orbits. Therefore, remember that in case of uni-electron system, arrangement of energy of orbital is like this. In case of multi-electron system, it is supposed to be in this form. Okay, we write this one. We have one more difficulty that we'll discuss in the next class. Copy down it normally. Draw the figure systematically. These two figures itself 4 marks question. Go ahead. Abdullah Sohail, you think you were present in junior Ames batch also? Is it so, Blita? Sohail, you were there in junior Ames batch? No, you were there because the same word, sir, we can consider Euler chart. In science, there is no word like Euler chart. There is a word called Euler diagram. That boy has written Euler chart. You are also writing Euler chart. Something is wrong here. Okay, no problem. I am a teacher. I don't want to undergo stupid situation. This is based upon Euler's diagram. Euler's diagram is a discussion. Later on, we'll come to discuss the pattern. And there is no Euler chart better. Try to talk in scientific way, right? Euler's diagram. Here, don't give importance to Euler's diagram. Give importance to the arrangement of orbitals, how I have arranged it. ठीक, कोई बात नहीं, वो गलत बोले बेटा, वो लोग गलत बोले, ऐसा नहीं है, कोई भी वर्ड वैसा नहीं है साइंस में. चार्ट नहीं है, वो फिगर है. चार्ट अलग चीज होता, फिगर अलग चीज होता. ये फिगर है ये, इट्स नॉट चार्ट, राइट? डायग्राम है वो, सिस्टमैटिक डायग्राम है, आप देखे होंगे डायग्राम वो, एरो मार्क्स है, तो दिट इज नॉट ए चार्ट बेटा। खैर चलिए कोई बात नहीं, अब सीख लीजिए, अब सीख लीजिए। वी आर इम्प्रूविंग, नो प्रॉब्लम, गो अहेड। इज इट ओवर? नो प्रॉब्लम, नो प्रॉब्लम। Draw energy level in a specific order. All right, that will stop here. There is one more problem with this that we'll discuss in the next class. Thank you. Assalamu alaikum.